Hi, John. So I had this program that I could use to film the screen so that hopefully you could get a math lesson on days like today when you aren't feeling well. And I made a video for you like 2 times, I think it was, and it kept just deleting things or something was going wrong. So I downloaded a whole new software and hopefully this one's actually going to work. Unfortunately, that took me the past about hour and a half. So now I only have about 10 minutes left before I have to go. So I'm going to try to just give you this lesson really short. It's super, super easy, so hopefully we can be on the right track for tomorrow. So from now on the days that you're not feeling well, I'm going to make you a video so that you can watch it whenever you need to, so that we stay on track. Because we have about 9 chapters left that we have to cover in about 5 weeks. So I'm getting just a little bit nervous. So hopefully your log test went really well, and Abby has a couple of things that she's going to bring to you. I don't know if you saw her today or maybe you'll see her tomorrow. I really need you to watch this video before then, before I talk to you tomorrow, so that we can just keep on moving. So Abby does have a practice log test for you. I know you already took the log test, but the practice test was homework number 74 or something like that, or 73. So I know that it's probably going to be really easy for you, but I just need you to do it just to complete as a homework assignment. So if you could get that to me and your log test, I can grade both of those and then we should be on the right track. So right now I want to talk to you about trig functions. It's really, really super easy on the first day. Okay, so talking about trig functions, up until this point, probably the only thing that you know about trig is SOHCAHTOA. So that means that the sine of any angle can be found by measuring the opposite over the hypotenuse. The cosine of any angle can be found by measuring the adjacent over the hypotenuse. And the tangent is the opposite over adjacent side of a triangle. So that's pretty much your knowledge of trig up until this point. We are certainly going to expand. Whoa. Okay. I don't know what just happened, but okay. We're definitely going to expand your knowledge of trig in the next couple of units, okay? So let's just keep going. So we're talking about angles as rotations. This day is really going to be super easy for you because I know that you're smart and I know that you get this stuff. So let me just put this over here so that you can actually see what I'm doing. Okay, angles as rotations. Let's see what Miss Tompkins has to say. Angles are measured counterclockwise from the initial ray towards the terminal ray. Okay, so that just means that in an angle like what you see in the picture right there, we have 2 different rays. And a ray is just a point or a line that starts at a point and extends on. So we have the initial ray, which is where our angle starts, and then the terminal ray is where the angle ends. So angles are measured in the counterclockwise direction. So they actually go positive as you go counterclockwise, which is kind of like counterintuitive. We don't really think that it should be like that. But if it's hard for you to remember, just think about the fact that we label our quadrants counterclockwise as well. This is the first quadrant, this is the second quadrant, this is the third quadrant, and so on. And the reason why we do that is because angles are actually positive going in that direction. This is actually the positive direction for angles. This is the negative direction for angles, which is kind of weird. Okay, so just some vocab for you. Initial ray, terminal ray, and so on. Alright, an angle is in standard position when its vertex is on the origin and its initial ray is the positive x-axis. So Miss Tompkins actually has a couple things on here that you don't need to know yet, so I'm just going to delete those for you. But you're going to see the term standard position on tests a lot. It just, if you see a question and it says an angle in standard position, it just means that the vertex is right here at the origin and that the initial ray, or the ray that we start at, is right here along the x-axis. This is the common standard angle. That's how a lot of them are going to be set up on your tests, on your quizzes, and that kind of stuff. Okay? So this is your initial ray, that's your terminal ray, and yet again, that's the positive direction. This is the negative direction in terms of angles. Okay? Quadrantal angles. Okay, so this is kind of like just another vocab word. We got a lot of vocab going on at the beginning of the section. Quadrantal angles. If you take that apart, I can actually see the word quadrant in there. So quadrantal angles are angles that just lay on the quadrants. Okay, so you should already actually know these. It's probably nothing new, nothing surprising. But if I drew out the 4 quadrants like this, we know that this is 0 degrees. You know that this is 90 degrees because this is a 90-degree angle. It's a right angle right there. This one's 180. This is 270. And this is also 360 if you go all the way around. Okay? So the word quadrantal angles, it just means that the angles that actually lay on the axes. Okay? So all of the angles within the first quadrant right here, those are actually the angles between 0 and 90 degrees. 0, 90, they are not actually in quadrant 1. Okay? It's called a quadrantal angle. It actually lies on those axes. Okay? When an angle is negative, its rotation is clockwise. I mean, that's pretty easy considering the fact that I just told you that counterclockwise like this is positive and clockwise is negative. It seems backwards from what we think that it should be, but in reality, it kind of makes sense based on what I told you about the quadrants. Okay, so this is the positive direction going counterclockwise. This is the negative direction. See? So easy. Coterminal angles. Okay, so this is actually pretty cool because we have angles, and if they share the same exact initial ray and the same exact terminal ray, it's pretty much like we have 2 angles that are the same thing and they're right exactly on top of each other. So if they're exactly on top of each other, they're the exact same thing. We just call them coterminal because sometimes we can give them different names. Maybe we're calling it the negative 72 degrees, but that's also equal to positive 288. Let me show you what I mean by that. If I draw a circle for you, unit circle, let's put our axes on there. Okay. So where would 288 degrees be? Well, this is 0, 90, 180, 270. So 288 is obviously past that. So this is my initial ray because it always starts right here on the x-axis. We went past 90, past 180, past 270, so it's probably about there. So if I label this angle starting at the initial ray and going in the positive direction, this is a positive 288 degree angle. Okay? But if you think about it, you could actually also go opposite and, backwards in the other direction. What if I went backwards in that direction? Well, then we'd only be going 72 degrees in the negative direction. Okay, so doesn't that kind of make sense? Because 288 plus 72, that's the whole 360 degrees. It makes sense. So what we're saying with coterminal angles is that sometimes there's more than one way to call one angle. Okay? So we could name it by the negative direction or the positive direction. Now on the test you might have something like that and it give you an angle in standard position that has a measure of negative 60 degrees and you have to rewrite it as a positive angle. You will see questions like that, okay? What else do they have? Alright, determine the quadrant in which each of the following angles lie. Okay, so let's just draw our axes really quick. I don't want that one. Let's just draw our axes. 0, 90, 180, 270. So which quadrant is 145 degrees in? Well, it's past 90, but it's not quite 180, so that means that's in the second quadrant. It's pretty easy. You're probably thinking that I'm crazy for even asking you these things. 303 degrees? Well, that's bigger than 270, not quite 360, so that's in the fourth quadrant. I'm sorry that I have to go fast through this stuff, but I think that you get it. 240 degrees, that's all the way down here in the third quadrant. If you want to pause the video at any time and do these for yourself before I get to them, that's perfectly fine. 412 degrees. Well, wait a second. Hold on. 412. That means that we went all the way around 360 degrees, and then we kept going. How far do you think we kept going? Well, how would we figure that out? If we know that we went once all the way around, That's 360 degrees. Let's figure out how much further we had to go after that. So what if we take 412 and we subtract 360? How much further would we go? We would keep going another 52 degrees. So that means that this angle went all the way around to 360, and then we went another 52, so we're probably around here somewhere in the first quadrant. Okay? That's also what I mean by coterminal. You could name this as 412 degrees, or you could call it 52 degrees. It's the exact same thing, just using two different names. 189, that's past 180, so we're in the third quadrant. Now, what about 270? 270 is exactly lying on that axis right here. Does that mean that 270 degrees is in the third quadrant or the fourth quadrant? Actually, because it's a quadrantal angle, I'm going to call it a quad angle, it's actually not in any of the quadrants. It actually is kind of like the border between those quadrants. So it's actually not in any of them. It's called a quadrantal angle. Okay? Which of the following angles is not coterminal to an angle that measures negative 120 degrees? Oops, sorry. Which is not coterminal. This kind of goes back to the idea that coterminal means that we can name it a bunch of different ways. So we're looking at negative 120 degrees. Well, let's see. In order to figure out what we're looking at, maybe we should rewrite that as a positive angle first. So negative 120 degrees, that means I went negative 90 and then a little bit more. So we're probably around here somewhere. Okay? So negative 120, how can I rewrite that as a positive angle? Well, I could take 360 minus 120 to figure out what it is. It's a positive angle, and that's about 240 degrees. So negative 120 degrees in this direction, negative 120, is the same thing as positive 240. Okay, so we're looking for angles that are not coterminal. Negative 120 and 240, those are coterminal, so that's not our answer. What about negative 480? That means that I went negative 120 in the negative direction, obviously, and then I kept going. So maybe let's see what happens if we took negative 120 and then we kept going another 360 degrees in the negative direction. So maybe subtract another 360. What would we get? Negative 480. Okay, so that means that if we started here at negative 120, and then we kept going all the way around another 360, we would end up right here, back exactly where we started from, but we just call it negative 480 degrees because that's how far we went. So that's also coterminal. All right, 600 degrees? Well, now we're obviously going in the positive direction, so let's see what would happen if we took 240 degrees, because that's what negative 120 is also equal to, 240 degrees, and then let's see what happens if we keep going all the way around another 360 degrees. So let's do plus 360, enter. That happens to be 600 degrees as well. Oops, wrong one. So this one is also coterminal, which means that 60 degrees is the only one that's not coterminal. That means that we had three different ways that we could rewrite negative 120 degrees. There's actually an infinite number of ways that you could do this, which is pretty cool. But 60 is not one of them because 60 is up here in the first quadrant. It's like right here. So that doesn't make any sense. Okay? So that's it for today. That's all the stuff that they covered in class that day. This is homework number 74. This is homework 74. So my notes say that you already did that, but just in case, I just want you to go back, double check those answers for me. I'm going to email you the answers to homework number 74. You can ask me about that when I talk to you on Monday. So hopefully you're feeling better. You can email me or text me if you have any questions. I'm going to post this on YouTube for you. Okay? So see you later.